confusion which prevails among the students is to find the direction of frictional force when one body is rolling over the surface and some force is also applied, impulse is also given to this rolling body. So then what is the direction of frictional force? When we had been doing the Newton's laws of motion, they were simply blocks. We knew that is which way the force is trying to move the body. It was simple to predict the direction of friction. But over here, when the body is rolling, so there are two effects. One is that is because of sliding, because of translation. The other is because of rotation. We don't know which effects predominates. So depending upon that, the direction of frictional force that can be found out. Let's understand this. So over here, let's say this is a rolling body of mass m and radius r. And this is on a rough surface, and this is at this instant, this is a point P of contact, right? And at a distance x from this, force F is applied onto this. So as a result, now when the force is applied, this is going to have a translational acceleration also, and this is going to have alpha also. So this is going to have translational acceleration as well as this is going to have alpha. To find the direction of friction, let's understand the acceleration on this point P, and first taking this surface as a frictionless surface. Let's see that is which way this system, this particle P has a tendency to accelerate. Once we know the tendency, that is which way it has a tendency to accelerate, then from there we can take this as a rough surface, and from there we can find what is the direction of friction force. So over here, if we see, if we directly slightly create some space, so one is because of this force, this center of mass will have acceleration. We know that is F is equal to m into A. So A is equal to F by m. So because of this, this point P, because of translational acceleration, this is going to have one acceleration which is F by m in this direction. Also, because now this force is applied and there is some distance, there is line of force from the axis of rotation, that is this. So there is torque is there, because of torque some alpha is going to be there. So what is the torque about O? If you find the torque about O, that is F into x, that is the torque. And that is equal to what? That is equal to IO, or simply let's write it as OI only, that is I into alpha. So alpha comes out to be Fx upon I. Because of this angular acceleration, this point is also going to have some acceleration in this direction, tangential acceleration, that is equal to, we know A tangential is equal to R alpha. So now this tangential acceleration is going to be equal to what? R, this is R only, R into alpha. Alpha is what? Alpha is Fx into I. So Fx into I. So now this point has a acceleration because of this translational acceleration as F by m, and because of alpha, this acceleration, tangential acceleration is Fx r by I. So the net acceleration of this is, let's say, F by m minus Fx r upon I. We don't know what is the direction. I have simply put it this minus this, I have put it, and that is, I have said that is, this is in this direction. So acceleration of this point P along this axis, Fx r by I. So when we rearrange, this acceleration of point P comes out to be F by m 1 minus Rx upon k square. It means if this is positive, so it means when 1 minus Rx upon k square is bigger than 0, so this is going to be positive. So it means this point has a tendency to accelerate this way. So as a result, the friction force will be acting in this direction. So if k square is greater than Rx, then certainly this will have a tendency to accelerate this way, friction force will be in this direction. Then depending upon if we have to keep it negative, then certainly if this is negative, then it has a tendency to accelerate in this direction, and that way the friction force will be in this direction. We have taken the various cases, that is if k square is greater than Rx, then friction force is in this direction. If k square is equal to Rx, if k square is equal to Rx, then the friction force becomes equal to 0, and if k square is less than Rx, then friction force is in this direction. So to find the direction of friction force, first consider this surface as a frictionless surface. And now find the acceleration of this point because of two tendencies. One is because of translation tendency, the other is because of rotation tendency. Because of translation, this force, there is going to be some acceleration, that is because of translation, there is going to be some acceleration, that is F by m is going to be some acceleration in this direction because of translation. Then F is given, X is given, you find torque, torque is equal to I alpha, from there you find alpha, and then you find A tangential is equal to R alpha. A tangential is found out. So over here you will find two acceleration. One is because of translation, the other is because of rotation. This is this is because of translation, because this is because of rotation, and you can find out that is which one is bigger. If ultimately the net acceleration comes out to be in this direction, so it means this point P has a tendency to accelerate over this surface, which is now has some friction over this surface. It has a tendency to move in this direction. As a result, acceleration will be in, as a result, the friction force will be in this direction. If A tangential comes out to be bigger than the acceleration because of translational acceleration, then it means the net acceleration is going to be in this direction. That is, this point has a tendency to move in this direction. As a result, because of irregularities, the friction force onto this will be in this direction, and onto this surface, friction surface, it will be in this direction. And so we can easily find the direction of frictional force.